Your boss wants an iPhone app and an Android app, and you are the only engineer they have. Meet Maya, handed that exact job with 1 year and nothing shipped yet.
I'm Taha and I have a solution for you.
By the end of this video, you will explain everything Maya builds, not just recognize the words. This is Flutter as one map of 9 ideas. The top rows draw a screen, while the middle rows make it move, and the bottom rows are how a real app holds its state. We start exactly where Maya started, with a weird question about buttons. Chapter 1. Maya's first instinct is the obvious one, to write the iPhone app and then write it all again for Android. Her lead stops her and explains that both apps are really one codebase written in Dart, which is Flutter's language. Maya assumes Flutter must be translating her code into real iPhone buttons somewhere underneath, and that one wrong guess is the most important thing to unlearn today. A normal-looking button on her iPhone screen is not an iPhone button at all. Flutter ships its own rendering engine, and that engine paints every pixel of every widget by itself. The operating system is never even asked for a button, so nothing it ships can ever fall behind. Old wrapper frameworks rented native parts from each platform and waited on every update, always a step late. Flutter instead builds its own parts from one blueprint and carries them onto every screen. Her code even compiles straight down to native machine code, so it runs at full speed. One codebase and 0 native widgets. So if nothing on that screen is a real button, what is it made of? Chapter 2. Maya builds Bloom's first plant card and reaches for the habit she learned everywhere else, one big card object with a dozen settings she can reach into and edit later. Flutter refuses to work that way, and understanding why is the whole model. Everything on the screen is a widget, and the widget is an immutable blueprint of the interface, meaning you describe it once and can never reach in to change it. Her card is not one giant class, it is a column holding a photo, some text, and a row of little icons. She writes a build method that returns those children, and Flutter calls it on the first paint and on every configuration change after. When Maya wants the card to turn green, she cannot edit that green in place. She has to return a whole new widget from build. It is the way an architect redraws a blueprint instead of repainting a finished wall. Everything is a widget, and a widget is a plan. But a plan of 50 plant cards still has to be arranged on screen. Chapter 3. Maya lays her plant photo, its name, and its price into a single row. Flutter greets her with the striped bar every beginner meets, a render flex overflowed by 42 pixels. Her first fix is the natural one, to wrap the whole row inside a bigger container and nothing changes at all. That is because a parent never actually gets to hand its child a size, since Flutter runs one layout rule in 2 directions. Constraints travel down from the parent to the child as a box of allowed sizes. The child then picks its own size inside that box and reports it back up, and only then does the parent set the final position. The row overflowed because its 3 children each wanted their full width, while the phone is only so wide. The real fix is expanded, a wrapper that tells the long name to take whatever space is left over. Constraints go down, sizes go up, and the parent sets position. The screen finally looks right, and then Maya taps the little heart and nothing happens. Chapter 4. Maya wires up the favorite heart and writes the exact line any sane programmer writes, setting is favorite to not is favorite. She taps it and nothing moves on screen, with no error and no crash to explain the silence. Here is the missing idea. A stateful widget is really 2 objects. The throwaway widget you write and a long-lived state object that holds the changing data. That state survives while the widget itself keeps getting recreated around it. But Flutter has no way to notice you edited a field. You have to tell Flutter directly by wrapping that change in a call to setState. That call flags the widget as dirty, which schedules a fresh rebuild on the next screen refresh. Maya wraps her one line in setState, and the heart fills instantly because the value was flipping all along and Flutter finally knew to repaint. For now, hold one simple picture. That setState rebuilds the widget. No setState means no repaint. But that simple picture is hiding something that should honestly worry you. Chapter 5. What's something that should be impossible? Maya's search box is half full of typed text, and the list is scrolled halfway down. An unrelated change on the page then triggers a full rebuild, and yet her text and her scroll position both stay put, even though a rebuild should recreate the widget. Time to repay that simplification. Flutter never rebuilds your screen from scratch. It keeps 3 separate trees. The widget tree is the cheap blueprint you rebuild constantly. The element tree underneath is permanent, and it is where your state actually lives. The render tree is the layer that paints the pixels. On every rebuild, Flutter lines the new widgets against the existing elements, and at each spot it asks one question: is this the same type as before? If yes, it keeps that element and your state untouched, and if no, it throws it away and builds a fresh one. That is why a play icon flipping to a pause icon updates in place. Widgets die every rebuild, but elements do not. And that one fact is secretly the engine behind Flutter's best party trick. Chapter 6. Maya needs to nudge one button color, and that button lives 5 screens deep behind a login and a slow 3-step form. In most toolkits, she would restart the app and log back in and click through all 3 steps just to see one shade. Instead, she just saves the file, and in under a second, the new color appears while she never leaves the screen. This is Flutter's hot reload, and it feels like magic the first time. It compiles only the code she touched into a small bundle, ships that into the still running app, and rebuilds the tree against the new code. Your state is untouched for the exact reason from Chapter 5. The elements holding it never went anywhere. There is one real limit worth knowing about. When Maya changes the actual shape of a class, the running app cannot reshape itself, so she needs a hot restart, which reruns the app from the top and wipes state. Hot reload keeps your state, and hot restart clears it. Fast to build with, but Maya's app is still an empty shell. Chapter 7. Maya's planned detail screen finally needs real data pulled from Bloom's server, and the network call is that awkward kind of value that does not exist yet. Dart calls that a future, which is one answer that arrives a little later, unlike a stream of many values over time. She fetches the plant over HTTP and hands the future to a FutureBuilder, which rebuilds the screen through 3 honest states. There is a spinner while it waits, an error if it fails, and the plant once it lands. Then a bug shows up, and the screen flickers back to the spinner on every unrelated tap. The reason is that she called the fetch function directly inside the builder, so every single rebuild fires a brand new request. The fix is to build the future just once, when the screen first loads in a spot called InheritedWidget. And the success code only means the server answered, not that the data is good, so she checks before trusting it. A fetch has 3 states, and an honest screen shows all 3. Now every other screen wants that same plant data. Chapter 8. Bloom now has a cart, and the little cart badge sits 12 widgets deep in the tree. Maya passes the count down by hand through all 12 constructors, and 10 of them do not care about carts at all and only forward it along. That misery has a name, prop drilling, and her instinct is to lift the count to a shared parent and set state there. That works, and it also rebuilds the parent's entire subtree for one tiny number. Flutter's real answer is the InheritedWidget, which you place once high in the tree so any widget below can reach up and grab the value. To reach up, the badge uses its context, which is just that widget's own spot in the element tree from Chapter 5. That lookup is a fast hash map read, not a slow crawl up the branches, and it rebuilds the badge only when the number changes. This is exactly how theme and media query already hand values down the tree. Stop drilling props and look the value up through context. And once you can look state up, you can finally own it properly. Chapter 9. Maya's cart now shows in two places at once, the badge up top and the checkout, and the two disagree. She cannot make the badge reach into checkout and call setState because one state object cannot touch another one's private data. The InheritedWidget from Chapter 8 can share the cart, but it is a frozen snapshot that cannot change on its own. What Maya needs is one thing that owns the data and announces its own changes. So she writes a cart model that extends ChangeNotifier and puts exactly one of them above the whole app. Every time she adds a plant, that model calls notify listeners its announcement. Each place that shows the cart wraps listenable builder, which rebuilds whenever it hears that announcement. Now the badge and the checkout both read from that one model and never drift apart. Chapter 8 showed you how to look a value up, and this chapter lets that value change and announce itself, which is the pattern provider and riverpod, and block all package. One owner and many listeners. That is the real shape of a Flutter app, and Maya just shipped one. Look at the whole map, because this was Maya's entire first year, and now you can explain every node on it. Flutter draws its own pixels. Everything is a widget is a plan, and one rule lays them out. setState asks for a repaint, 3 trees keep your state alive, and hot reload rides on those very same elements. A future fills 3 honest states, context ends prop drilling, and one notifier feeds many listeners. That is about 70% of Flutter, a real working model of every node here. The last 30% is reps, actually building the thing with your own hands. Flutter, 25 lessons on iCommit. Go build Maya's app yourself.